Okay, up until now, I've only been using logarithms as some kind of a mysterious function that somehow will undo the exponential function. So what we've done so far is to say, okay, if we have an exponential function that we are trying to solve, and the variables in the exponent, then what we have to do is take the natural log of both sides of the equation, because the natural log somehow mysteriously undoes the base of e, so that we're left with the exponent now down out of the exponent, and then we just have to do some simple algebra and use the calculator in order to come up with the answer. But I'd like to give you a little bit more of an explanation about where the log comes from. So basically, we are used to an equation like this, where you've got a base and an exponent, and we're asked to figure out what the result is. So of course, 2 raised to the power of 3 is equal to 8. But suppose what we really wanted to find was the exponent. So the exponent is the unknown. So here we'd say, well, what number would I raise 2 to in order for my result to be 8? Well, the way we write that function is, here we have the base 2. If I start with a base of 2 and end up with an 8, what must the exponent have been? So in order to say that's what we want to do, we call it a log. So here's how it would be written. Log base 2 of 8 is equal to 3. Basically means the same thing as 2 raised to the 3 is equal to 8. What power do you raise 2 to in order to get 8? The answer is 3. So let's go back and forth with this one to see the correspondence between the log function and the exponential function. Again, 2 raised to 3 is equal to 8 means the same thing as log base 2 of 8 is equal to 3. So here it is written in exponential form. This is exactly the same thing written in log form. Okay, so let's look at a few other examples of finding logs. So this one is saying log base 3 of 9, what is that? Another way of saying it is saying, what number do I raise 3 to in order to get 9 as the result? Of course, the answer is 2, because 3 raised to the 2 is equal to 9. Here's another one, log base 3 of 27. What is that? Another way of saying it is 3 raised to what power will give me 27? Well, 3 raised to the 3 gives me 27. Therefore, x is equal to 3. Log base 5 of 25. What number do I raise 5 to get 25? The answer is 2. X is equal to 2. Next, I'm being asked, what number do I raise 7 to get 1? Well, hopefully you remember, if you raise any base to the power of 0, you get 1. So 7 raised to the 0 power gives me 1, so x is equal to 0. Here's a repeat. What number do I raise 3 to get 9? The number I raise 3 to get 9 is 2. What number do I raise 7 to in order to get 7? Then the answer is 1. What number do I raise 7 to get 49? The answer is 2. Now here's a really silly one. What number do I raise 7 to in order to get 7 to the 5? Well, x is equal to 5, right? Because if I raise 7 to the power of 5, I will get 7 to the power of 5. Another silly one, what number do I raise 4 to in order to get 4 to the 1/2 power? Well, the answer is 1/2. Now, what this brings to mind, and one of the reasons I'm looking at this, is to do a little review of what fractional exponents means. So hopefully you remember that the square root of 4 means the same thing as 4 to the 1/2 power. So if you are given log base 4 of the square root of 4, you may want to first rewrite it as log base 4 of 4 to the power of 1/2, and then it becomes more obvious that the answer is 1/2. Or it could be written like this. For what number do you raise 4 to get 2? Well, in that case, you want to remember that the square root of 4 is equal to 2. So I would rewrite this one as log base 4 of the square root of 4. What's that equal to? And of course, that's the same thing as log base 4 of 4 to the 1/2. Therefore, the answer is 1/2. Now, this next one will bring to mind what happens when we've got a fraction, or what's another way to write fractions. So if you remember that if you remember that 1/3 means the same thing as 3 to the negative 1, see? 1/3 and 3 to the negative 1 are the same. Therefore, if you remember that, it's easy to know that in this case, x has to be equal to negative 1. Now, there are two bases that come up a lot in mathematics and science and business. So experts came up with some simplified symbols. So here we've got log base 10 of 10. It's pretty obvious that that's 1, because if you take 10 and raise it to the power of 1, you get 10. Well, this equation means exactly the same thing. So if you ever see a log that doesn't have any base, log, no base, you can write in base 10. Log without a base means there is an invisible 10 as the base of the log. So log of 1 means what number do you raise 10 to in order to get 1? And I made a mistake here. This answer should not be 1. It should be 0. 10 to the power of 0 will give you 1. Here, how about this one? Log of 0.1. Well, remember, 0.1 is the same thing as 1/10. 1/10 is the same thing as 10 to the negative 1. So we're really saying, what is the log of 10 to the negative 1? Or what number do you raise 10 to get negative 1? Negative 1. This, we're asking you, what number do you raise 10 to get 0.01? The answer is negative 2. The other number that's used a lot as a base is the one we've been using, the base e. Okay, so log base e of e to the 4th would actually, of course, be 4, because e raised to the power of 4 will give you e to the 4. Well, these two equations are the same thing. Log base e means the same thing as natural log. Okay, so if you were asked for the natural log of e to the 5. That's the same thing as saying log base 5. I'm sorry, log base e of e to the 5, which is, of course, 5. Okay, now just one more thing we want to look at. And I think after we finish this, you should be able to do all the problems in the problem set about logs through, I think, number 11. Okay, so let's do a little review of exponential equations and their graphs. Here is a graph of 3 to the x. This also could be the graph of f of x is equal to 2 to the x.